Welcome to qnawire.
So coffee is being poured into the mug shown in the figure. So the figure is right here. And we're being asked to measure in volume per unit time. And we're being asked to sketch a rough graph of the depth of the coffee in the mug as a function of time, and account for the shape of the graph in terms of concavity. So what is the significance of this inflection point? So this is a kind of a rough sketch of the pitch to coffee that's in the textbook, but you can see that it is very wide at the bottom, and then gets narrow, and then gets wide again. So that's just kind of a general idea of what the graph looks like. So this is going to be, the x-axis is going to be depth. So the depth of the, and then the y-axis will, the y-axis will be depth, and the x-axis will be time. So when we first begin pouring coffee at a constant rate, the depth won't be increasing as much because it's wide, and it takes more coffee to fill up, so it's less being achieved, and then it's going to sort of increase as it gets into the more narrow range. It gets more into the narrow range, it increases really fast, and then it gets wide again and sort of does the opposite and does what had happened in the beginning. And so we have an inflection points. So this is concave up, and then we have concave down. So the inflection point is somewhere in the middle. And so the significance of the inflection point is that at this point, the coffee is being poured faster at any other point. So it is being filled up, like the height or the depth of the coffee in the mug is increasing at a faster rate than any other point in the coffee mug. And that's really the interpretation for the inflection point, and that's really what's really neat about the inflection point. It tells us about the fastest rate at which it is tells us a lot about different situation. In this term, tells us that the rate of the coffee is the depth of the coffee is increasing at a faster rate than any other point.